It won't get you. Okay, so are we good? I'll just start here and then. So, what do you think that the question for this one asks us to do?
Solve for X.
Solve for X, right? It was probably a solve for X type problem. So, what I'm looking here is a couple things. I've given you a lot of beautiful hints this week, talking a lot about different things that we could do to attack these problems. I see a squared, a squared, a squared, a squared. So what could I potentially do? Yeah.
Well, we can combine like terms.
We could combine like terms, okay? So let's go ahead and do that. That's 4 sine squared equals 6 cosine squared.
Yep.
Yeah? A lot of people are taking and making the sine squared into the cosine squared and doing all that. What was a hint I gave you, though, that perhaps could work? Divide
By cosine squared.
by cosine squared to make it tangent squared. Remember, I told you, if the word sines all have the same exponent, make them into tangents. If they all have the same exponent, in this case, they all have squared, right?
Yeah.
So I'm going to divide everything by cosine squared.
That's okay.
You did it another way and you got the same answer, I'm sure.
So what would happen if you had 4 sine x equals 6 cosine squared x? That wouldn't work.
Right, you would not.
So would you want to maybe make cosine squared 1 minus sine squared?
Yes.
Because then that way.
And then
Yeah.
it would scream, I'm a trinomial, factor me.
Right.
Right. Okay, so this one is going to be, but you went and did it, you converted sine squared into cosine squared, or vice versa.
I'm not sure what
Yeah, from looking
Yeah.
at what your work was, he actually went and made one to be 1 minus cosine squared, combined like terms, and got to the same answer in the end. We're just trying to make life easier, you
Yeah.
know? Okay, so 4, and then sine squared divided by that would be tangent squared equals 6. Yeah? Okay. Okay, so then I'm going to, it's 3 over 2, okay, so we reduce it to lowest terms.
square. Yeah.
Take the square root, and what do I get?
Square root of 3 over 2.
Positive, negative.
There we go.
Positive.
So what was the question that Nick wrote to me? The answer on the mark scheme has 4 answers.
Oh,
Yeah.
that's what
I'm only getting 2 answers. What the heck am I doing wrong? And I said, remember when you take a square root of something, it's a plus and minus. Because when he didn't do that, he's saying, oh, tangent is positive only where? Right? Remember that's how we went through that process?
One and
Right. So tangent would be positive
Right.
here and here. But because it should be plus and minus,
It's everywhere.
it's all 4. Right. So it's a very easy gotcha. You just want to make sure you don't let it get you. Yeah.
Do you notice, like sometimes with the mark scheme, what they do is like for the tangent, like they found a reference line. But I thought for tangent it repeats every 180, so you just add 180, that gives you the answer in the other quadrant. Add 180 again.
Yeah, that's the reference line you're referring to. It's just weird. We know it as a 180.
But that'll work every time for tangent.
So where does square root of 3 over 2 happen?
tangent is
You'd have to take the inverse tan.
sine of cosine.
So you have x is equal to tan to the negative 1 of positive square root of 3 over 2.
And negative squared.
Right. Tan to the negative 1 of negative square root of 3 over 2. So each of them have an answer. And I'm in what mode?
Radian, or
Degrees.
degree. Yes.
Because it says 0 to 360, so I'm in degree mode. What is it?
56.3.
56.3 degrees here.
Wait, what?
I didn't get that.
Okay.
Why?
Uh-oh.
You need to put the square root of the 2 too,
Oh,
right?
I didn't know the square root. Okay.
Yeah, the whole thing is square rooted.
Yeah, okay.
Yeah.
That's just my
I got
50.7.
50.768.
Yeah.
So what are we rounding to?
50.76.
7684, so. what do you
Didn't
want?
they tell you, the directions on the front of the test, I
Oh,
think,
okay.
say.
360?
In the case of degrees, do it
it's
1 decimal.
1 decimal place for degrees, right?
Okay.
So what would we?
6 to 28.
I think that's what the directions read, right? Yeah.
Mhm.
And then what was a tan of negative square root 3 over square root of 2 while we're there? Is it? I just want you guys to, I'll double check and make sure. So,
I got it.
you got what? Negative, yeah.
Yeah, hold on. Yeah, I got that.
Yeah, got the same thing.
Okay, cool, we're all on the same page.
But you can,
Alright.
yeah,
So,
But you gotta get that to positive, because it's 0 to 360.
yeah.
which we can do. Mm-hmm, we can do that. So we have to talk a little bit about how this works, right? So the 50.8 is located approximately like in between these two guys, right?
Yeah.
So what you were referring to earlier is that our reference angle would be the one that's from here to here is 50.8, right? So it's gonna be 50.8 as well.
Uh-huh.
But we know that's 180.
And it's always 180 for tangent.
Uh-huh, exactly,
But, yeah. Okay.
right? So what's 180 plus this? 30. Okay, that's perfect.
Yeah.
So we know if it's 50.8 from here, we're gonna add to 50.8 from here. All right, everybody so far so good? Now, negative 50 is actually located down in here. So this is between here and here, right? But because that's not, because it's not between 0 and 360, we have to figure out what place between 0 and 360 actually falls in that same spot.
So then you just change it, so it's.
So you do 360
Minus 50.8.
minus 50.8.
Okay, which is 309.2.
So what do you get?
309.2.
So it's 309.2.
Need to check.
Yes.
Wouldn't you also take, what was it, negative 50.8 and add 180? And that'll give you your answer in the second quadrant?
Yes.
Okay.
So you could take negative 50.8 and add 180. And what do you get when you do that?
129.2.
They're not in order, but it doesn't matter. 129.2.
Two.
Do you have to make them in order?
No.
Okay.
As long as you have all four. Is everybody good? That was a really good problem. I'm glad you wrote to me on that one. Now, he actually did it. He actually did it where he took the sines and cosines and converted one of them into sine squared or cosine squared, I don't know which one he did. And then he actually got the same answers. But this to me is, and his was,
What
like
answers did you get?
7 steps down.
What answers did I get?
Same one.
I think so.
You got all four?
Yeah,
Oh, it was just the.
after we talked, he got all four.
Yeah, because I thought it was just 2, and then the marking said 4, and then I just didn't know where that was
And
coming
then you
from.
didn't know where it comes
Yeah.
from, but what we have to remember is when we solve a square root,
Yeah.
you got 50.8, 129.2, 309.2, and 230.8.
Yeah. Because that's what the mark scheme said, so I think I just had the 50.8 and the,
Oh, 230.
230.
yeah.
And what you did was you went, the cosine squared, you converted it into 1 minus sine squared. So it's fine. I was just trying to give you guys hints to make it a little easier. Because yours was 1, 2, 3, 4, 5, 6, 7, 8 lines to get to this. So ours was 1, 2, 3, 4, 5. So it's a few less steps. Either way, it
Less
doesn't say.
mistakes.
Yeah, hopefully. The only way the tangent works though is if, although remember there was one problem that had everything in terms of sines and cosines, and the largest cosines was like a cosine squared, and we divided by all of it, and we ended up with like tangent to the, I don't know how to explain it, it was a long time ago, and they had a bunch of different tangents, and we could unfoil those. Yes.
Was that where we had to do factor by grouping?
No, I know what you're talking about. This one is we divided everything by cosine squared. So we ended up with a +1 for the cosine squared, and then it worked out that there was tangents. It's been a long time that we've done that, yes.
So, if you didn't realize that they weren't all the same,
And
powers,
you went sine squared equals 1 minus cosine squared, but the Pythagorean, that's
that, or
perfect.
like, if you didn't know they all have the same power and you divided it all by both sides, like, cosine squared. I guess that's more common. Or like, if I divided by cosine only.
Well, if you divide everything by cosine squared, well, cosine only won't work out, because you're gonna be left with sines and cosines. You wanna, if you're gonna divide by cosine, you wanna divide by the largest exponential power of cosine. So it can at least get one of the words cosine to go away. Yeah, it has to. All right, are we good? So those are 2. Anybody else study over the weekend that might have had questions? Nick was the only one texting me. Yeah,
I had some questions on the test you put on Edline.
Oh, good.
I just need to find it.
okay.
So this was the May-June 2016/12,
Uh-huh.
I believe.
I think I'm gonna leave this one up there for the fourth period. Okay. Okay, yeah, thank you. It gives us more room to work with. All right.
So, which one are we doing now?
Whichever one you think. I'm game.
Because I had some questions about, this was the 12 test. Because I know for part II, I just wasn't quite sure, how do I expand both of them out?
I wanted to go over one of those with you. So, okay, so this one is from May, June. It's the one that I put on the website. May, June,
2016/12.
number 4. Okay, so the first is, it says, find the term independent of X.
Uh-huh. Where the x's cancel.
Right. So independent of X, right? I'll get to the second part in a second. So the first one said, find the term independent of X. We can do this, right? So independent means there's gonna be no X's when we're finished. So I know that I have a couple things to fill in. Okay. Here's where I start, right? I know that it's gonna be a choosing problem,
Yeah.
right? And I know that my first term has an exponential power. I know my second term to its fullest with the negative there has an exponential power. I know that this plus this has to be 6. And I know this last term has to be this. Okay, so those are all the little techniques that we have. Okay? So what two things that add up is going to make this and that guy down below go away?
3 and 3.
3 and 3.
My options would have been like a 1 and a 5, or 3 and a 3. Hello? You're gonna be in the front conference room. Yeah, and it's the beginning of fourth period. So you guys all agree it's 3 and 3.
Yeah.
Everybody okay with that? Because the 3 on top and the 3 on bottom, when you divide, you subtract. So I know that this has to be a 3. So the answer to this is going to be 6 factorial, 3 factorial, 3 factorial, or use your handy dandy calculator and do what you do, right?
Yeah.
And then this is going to be x to the third. And what's a mistake people are going to make for this problem?
They're not going to distribute.
They're not going to remember to take this and distribute it to both pieces, right? So negative 2 to the third,
Negative 8.
negative 8 over
X cubed.
x cubed. So the x cubed cancels, which is what we want to happen.
Choosing is 20.
That turns out to be 20. Thank you.
Times negative 8 is negative 160.
So to me, that's an easy, it was 2 points. Decent 2 points, yes.
What I did for this was I expanded it out to like the, let's see, 1, 2, 3, 4 terms, and then I found where it canceled.
Okay.
Because I didn't know to do that trick that you did there.
Okay, so they're not going to mark you wrong for standing it out, but you are taking precious moments off the 1 hour and 45 minutes.
Mm-hmm.
I mean, how much longer does it take for you to set it up? Not much. It's just if you understand how that kind of puts itself together, it might help.
So it's just two numbers that the two exponents should add up to the 6, and then the last one should, the one on the bottom should be that one.
Right?
It doesn't really matter, but
Well,
the choose thing.
yeah, I know.
But that might not always be that way.
Yeah, just kind of keep it though. Kind of,
Alright.
Yeah, just kind of try to keep it. Okay, so the next one, it says find the term independent of x. So we still have more to do. So the next part is asking us to do the same thing, but we got a dilemma. It wants us to distribute that through.
So we're still finding the term independent.
Uh-huh. So it wants us to find the term independent of x. So if Nick had done his problem and he expanded it with like the first 4, he might have been more in luck than what we are now, because we actually could use the first 4 to see what was going to happen. Let's kind of visualize what's going to happen with this. If I expanded this whole thing out, right, I would have, if I expanded the whole thing out, I would have 7 terms. Everybody okay with that?
Yeah.
The first term would be like 6 choose 0, x to the 6th, and then negative 2 over x to the 0, okay? So if I expand it out, then I would take the number 2 and I would distribute it through. What I need to figure out is where does 2 hit that's going to cause the x's to be gone. So 2 doesn't have any kind of influence on x's whatsoever. Do you agree?
Yes.
Because 2 is just a number.
Uh-huh.
So if I was to do that, doesn't it make sense that this is the one that we want it to hit?
Yes.
Because if I multiply this through and when I hit 2 to this, it's going to be 2 times negative 160. There's the number I'm looking for.
That's it?
That's that first one. So 2 times my number is going to be negative 160 because we just found it. So what? Negative 320 plus. Now what we have to do is we have to figure out when I take 3 over x squared and I distribute it through, where is it going to cause it to zero out? So let's kind of think about the numbers at work here. So do you agree in this one, the first, it would have been like x to the 6th and then negative 2 over x to the 0, right? Do you agree?
Yeah.
That's the first term. If I multiply 3 over x squared by it, what happens?
Nothing.
I got x to the 2nd down below, x to the 6th, and no x. So this would be x to the 4th.
So still got x's.
So it's got x's, and that's not the one I want.
So 4 and 2.
Yeah, because
Yeah.
That's what we need, that's what we need, is 4 and 2.
Yeah, because you want the numerator to be 2 extra x's than the
Right.
denominator.
Right.
to compensate.
Yes. Oh, you're getting the answer.
Yeah.
Oh, okay. Yeah. Good. Okay. I was just going to show it. Kind of, I'm sorry. I got lost in my own little. I'm still tired from the other day. Hanging out that way. I know. I'm showing the work.
Oh, okay.
So like this one, hello, why does that one not? Okay, so why does x to the 5th, x to the 1st not work?
Because the x's don't cancel.
Right,
But like when I expanded it out, I see where it does cancel.
I'm sorry, I'm listening, go ahead.
I think it's isn't it, we said it was to the 4th, x to the 4th negative 2 over x squared. That was it.
Those big paper clips, you think? They don't look as good.
Because then we've got the x squared times x squared, which is x to the 4th, and then we've got 2x to the 4th, which cancel out.
Right. Is everybody on the same page? Paper clips. Here's the big ones. Those are big guys, aren't they? Oh, it's not been very good. I'm not doing very well here. Going in. Apparently I don't have big paper clips. The heck? Maybe I have.
What's considered big, a normal size paper clip?
I just know it's Patless. If you don't send the right kind, things might melt down.
I saw that video and I was like, David hit him hard.
Well, yeah, Miss Kate,
Did
who
it?
broke it? Who broke his leg?
It was just, I forgot who did it. It was one of the running backs, like, nailed his leg. Well, that's not less fault. He should have never been walking.
He said he was in the line of play, and that's what happened. And you should never have your back to the line of play.
Oh, did Devin not show me the video?
Huh?
Did Devin not show you the video?
He's not showing me.
He has it.
He didn't show me till this. He didn't tell me about it till this.
What are you looking for?
Big paper clips.
Big
I
ones?
didn't have, like, clear thing. Is that big
He
now?
wants a big box of them.
Oh.
Alright.
Miss K,
Yeah.
I'm getting negative 680, and the mark scheme said negative 140.
Okay, let me finish. Okay, so
When you squared the 2, did you get positive 4 or negative 4?
When I squared the 2, which one? Oh wait, I put negative 8. I thought I was cubing it for some reason.
No, yeah.
so there's your numbers, right? Does that make sense? So I have the x squared and this x to the 4th and this x squared all cancel out, which is what we want.
Yeah.
So I have-
Turn that too.
12,
Right, so I've got 3 times negative 2 to the 4, the second,
4.
Four.
So 12
so 12.
Plus times the choose.
times.
And the two.
6 choose
2
2.
is 15.
Thank you.
So it becomes 180.
So plus 180.
And then that gets you negative 40, which is what the mark scheme said.
Right. All right,
Miss
let
Kay?
me, yes,
Why
Real-
is it-
go ahead, go ahead.
Why isn't it like times 180? Why is it plus 180?
Because what's happening, let's talk about realistically, like if I took 3 times x squared, oh wait, hold on. If I took 3 plus x times x squared plus 2x plus 3, let's talk about like what happens when we do that. We take this first thing and we multiply it by each piece, right? So we'd have 3x squared plus 6x plus 9.
Yes.
Right? Then we take this one and we multiply it all the way across. We line them up and we add up like terms. So this would have been like x to the third plus 2x squared plus 3x. So in actuality, you take the first piece, multiply it through, the second piece, multiply it through, add like terms. And that's what you're doing. You're not going through the process of multiplying everything through. You're just going to do that and then add like terms. Let me see if I can make a quick phone call. The lecturer.
I'll put it on pause.
What's the next one?
So it was actually number 5 on this page. I've been looking at it and I've just confused with.
Sure, okay.
I'm not sure where they're getting their information from.
Okay.
Looks pretty difficult.
Draw a triangle better than what Nick does. Just saying. Probably the only thing that I can do better than Nick. Okay, so there's my triangle. And this kind of looks like what Nick drew as a triangle, right there.
Mine was like an obtuse triangle.
You had something going on.
Obtuse triangle that just reached over into the second quadrant.
It was cute as heck.
It was breaking.
I didn't know what you meant.
It was breaking the laws of math.
It was, and I loved it. You were a little bit of a rebel that day.
They should go to math jail.
I was worried about you. All right. In this diagram, the triangle ABC is a right-angled triangle. So I know that this is 90 degrees, also known as pi over 2,
Yeah.
right? I know this is pi over 3 because that's given.
Uh-huh.
So do I know this whole thing? I do. Whatever pi over 2 minus pi over 3 would give me that extra one over there, yes.
Well, doesn't, because all 3 angles in the triangle have to add up to 180, which is pi in radians.
Sure.
So,
Why is-
yeah,
Isn't that 60 degrees?
pi over
Right.
3,
And that's 90, so it's a 30, 60,
30, 60, 90.
90. So what would that would have to be?
30 is pi,
Pi over,
pi over 6.
yeah. So that whole thing up there is pi over 6. Everybody in agreement? I didn't really think about much, but, so
Yeah.
this whole thing is pi over 6. Okay,
Yeah.
so that's a now given. All right, so M is the midpoint of BC. It is given that the angle ABC in pi radians and the angle BAM in theta radians. Okay, noting that the lengths of BM and MC by X, so they're the same.
What
Can you
point's what
explain
letter?
this?
These are both X.
No, 'cause
Like the A, B, C,
Oh,
M.
oh, you need to know all that? Really? No, I'm just kidding.
She's confused.
You guys are,
A, B, where is it?
you guys are high maintenance. That's funny. You couldn't read my mind?
No.
Shoot, nobody else can either.
Like that.
You're probably gonna be very happy you can. All right, AM. I wanna find the AM in terms of X. So I need to find AM in terms of X. So. I know that this is also a right triangle. Yeah? Are you with me? Yeah? Right? Okay. I know this thing is theta, the little guy. So what's this angle?
It's going to be,
Pi over 6
minus theta.
Pi over 6 minus theta. It's another one of these fun ones. So that's pi over...
Yay!
Wait.
I said great.
Oh, it is a wait. Okay. So if I know this is pi over 2, right?
yes,
I know this plus that has to be pi, right?
yes.
I also know that this plus this has to be 90 degrees, pi over 2. You guys with me there?
Oh, because since that's 90, then the sum of the other 2 angles is
It has to be
90.
90. So can I take pi over 2 minus that and get that?
Yeah.
No, yeah, maybe? Yes, no, yeah, yeah?
Say that again.
Okay, so, I know this plus this has to be 180,
Yes.
Angles, yeah.
right, or pi.
Yeah.
This is already 90 degrees of it. So I can actually get rid of pi over 2 of it, and so I can get rid of this, and know that this plus this has to add up to 90, also known as pi over 2. So if I take pi over 2 and subtract that, I get this. Life is good. No? Okay,
I
so,
get what you're saying, but it's just like I would never think to do that.
okay, so how would you have done it? I mean, because it's still more ways to do it. That's fine. You would probably do pi minus pi over 2 minus pi over 6 minus theta, right? You would cry.
Yeah.
That's the third choice.
Me too.
Maybe they'll give you a point for that.
If there's
Maybe
tiers,
tears on the
you
page.
know what you're gonna have to do is kind of outline the tier and say, this was a tier, by the way.
Tears shed by my pathetic face.
Ah, that's funny. So, pi over 2 minus pi over 6 plus theta. So, get a common denominator. 3, 6 minus 1, 6 is 2, 6, 5 plus theta, also known as pi over 3 plus theta. Check my work.
Use sine, cosine, tangent.
Correct.
Okay.
We're looking for AM.
Adjacent over hypotenuse.
Right.
So cosine.
So this is hypotenuse, right? And we want to do it in terms of x. So this is the one that we're looking to use, the adjacent. Everybody okay with it? Why could I not just kind of run it off of this one? I could have. Could I have run, I mean, I couldn't. Could I run it off of this one? It would have been opposite over hypotenuse. It would have done the same thing. So I really, rather than your tiers, I could have just used this guy and done the same thing. Tiers do happen, but, okay, so, here we go. So cosine of x is equal to adjacent over,
Why cosine of x?
Shouldn't it be cosine of pi over 3 plus theta?
Yeah.
yeah,
Yeah.
Is equal to adjacent x over am.
Even if you're making up another variable, don't use one that's already there, please.
I'm not.
X sub 2.
I should just still be sleeping.
It's x sub 2.
Except whatever, huh? Oh, that's funny.
am. And then
Which is
solve.
what we're solving for.
So then am is equal to x over cosine of pi over 3 plus theta.
It's not pretty. And there's your answer.
Really?
Really.
And that was part I.
Part I. Find
Number-
AM in terms of x.
Was there a part? There's a second part, wasn't there?
Second part. Show that theta. Oh, gets even better. Says show that theta is equal to pi over 6 minus tangent to the -1 of 1 over 2 square roots of 3. And this is only a 2-point part.
They had fun with that.
They did have fun. Okay, so they want me to solve for theta. Yeah.
Well, you could actually find angle BMA, because if you know that they're supplementary angles, so you could say pi minus pi over 3 plus theta is going to be angle BMA, and so now you have all the angles.
Okay. But we're trying to actually solve for theta.
That might come in handy later on.
It might,
Yeah.
But the thing that I'm looking at is, yeah, I'm looking at tangent, basically, right? Why am I looking at to work with tangent? Because the answer has a tangent in it.
Yeah.
Yeah.
Oh, so it's pi over 6 minus something, and we have a pi over 6 minus something over an angle A. Pi over 6 minus theta, right? So are we going to use something with that angle, I'm assuming?
Probably. I know, so let's talk the big picture here. I know that we have, this is my big right triangle, right?
Yes.
Yeah.
And we have the,
Yeah. Angle BAC is pi over 6, right?
angle BAC
And
is
then
pi
if
over
you
6.
subtract from that pi over 6 minus theta, then you're left with theta.
Correct,
So that's, I think, what we want to do.
but it's not a right angle. This is not a right angle, so we can't use sine, cosine, tangent
Right.
for this at all. Yes,
We have to either use the small triangle MAC or the big triangle ABC.
So yeah, that's why we do the big triangle, the angle, the A angle of the big triangle minus the small triangle that still has the right angle in it. Angle BAC minus angle MAC.
so angle, how do we show that? Angle BAC minus angle MAC. Okay,
Mhm.
so what's angle BAC?
Pi over 6
Yep,
minus angle MAC, which is pi over 6 minus theta.
Yeah, but we're solving for theta, so we don't want to do that.
right.
So we want to do that in terms of the other sides.
Um,
So it's going to be the arctan of.
Well, the stop, let's, so I know that this is my hypotenuse, right?
Right.
And I know that we have this as a given,
mhm.
right? So if it's tangent, opposite over adjacent, but there's no theta involved. So we're gonna use this guy up here, no, still theta. The little guy. Tangent here is, this would be opposite over adjacent, right?
The mark scheme did something with AC. Tangent of angle MAC is equal to x over their AC.
Yeah.
Which is what we don't know, AC. Tangent of pi over 6 minus theta, and that's opposite.
What's your reference angle?
The one other angle A.
We can actually find AC there.
What if we found AC? Because isn't the whole thing, you said it was 60, 90, right? So if we use the properties of that, that means the short
Oh, good
leg
job. This is 2x,
is
What's
2x.
right?
So the hypotenuse is what, 4x, and then that means AC is, what's it, square root of 2 times?
It's
2x.
a 1, 2 square root of 3, right?
1, 2,
Is it
square root of 3.
square root of 3?
The hypotenuse is 2. The one that's opposite the 30 degrees is 1, and the opposite of 60 is square root of 3.
This one you would cry, there would be tears.
This would be a tier one?
I think it would be a tier 1.
I feel like
I wouldn't even look at
has
this.
triangles
I would
in it,
just
I
show
just
you
can't
the
see
feelings.
It was only 5 points. You might be able to get a point or two, though.
Now it works. Now we can actually go through the process, and this is the opposite over adjacent. So tangent of,
Just call it angle.
pi over 6 minus theta, right, is equal to opposite over,
X over 2x.
This K?
yeah.
I understand like the 30, 60, 90 has got special properties, but how did you get 4x and 2 over square root of 3x?
You just what?
Like where did that come from?
It's a 1, 2 square root of 3.
But how did the 1 become 4x?
It might be 2 times the square root.
That's more money than I was putting in my bank account.
Probably.
That looks better. Yeah, I'll go with that.
Yeah.
That was a toughie.
So we're not done.
Wait.
It's nothing.
And they only gave you 2 points for part II.
Are you kidding?
This is only 2 points. I was
Oh, no.
Yeah.
Bye.
What?
Sorry.
And then they've got an easy one for like 6 points.
Right?
There it is.
That is.
Rather do that binomial expansion than I'm doing it in
Got
5
it.
seconds.
We got it.
You got it.
So, well, The X is canceled.
Do you think you would get full points if you took if you took the Cambridge test?
12 years after teaching it, maybe yes, but
First
years,
time?
no.